Frog Environmental are an environmental consultancy. We specialise in freshwater ecology and freshwater environmental science. I'm Leela O'D. I'm one of the founding partners in Frog Environmental alongside my colleague Richard Hayne. We've both been working in the environmental sector for over a decade now, and have got a huge amount of experience in both ecology, water quality and waste and contaminated land. Over the years that Richard and I have worked in the freshwater environment, we have really noticed the increased burden nutrification is having on our water systems. It is going to be one of the biggest problems we face, and so we've been looking for a number of different options to try to reduce the nutrient inputs into the water system, and once they're in there, to remove them altogether. One system that we have come across now is Biohaven. It is basically a floating island, but is completely different to any of the floating islands that we already have in this country. The matrix itself, which the plants grow upon, has got a huge surface area, which means that you start to build up a biofilm, and a different part of our natural ecosystem really kicks in, and so we are allowed to cycle up nutrients within our water space and create a new natural habitat whilst we're doing this. Since we've investigated this, and we really believe that we can find a great application in this country for it, we went to meet the inventor, Bruce Carnier, over in his home in America, and Richard has carried out an interview with him to discuss the benefits of the Biohaven system.
So Bruce, how does a Biohaven floating island work?
Biohavens are our man-made effort at replicating nature's model of the wetland. We actually are hoping to concentrate nature's wetland effect, and that effort, as manifested by floating treatment wetlands, otherwise known as Biohaven floating islands, is essentially oriented around concentrating two huge variables, one of which is surface area, the other is circulation. When those two things come together, it's not about plant life. It's not about engendering macrophytes. It is about growing biofilm-generating bacteria. That's our focus.
And so what grows on the surface of the Biohaven matrix and the plant roots to make it so effective?
You know, it's amazing how when we first got into this business and we would explain that, boy, we're interested in developing floating islands, people would look at the islands, they'd see the plant life, and they'd think, oh, you're farming nutrients out of the water. Wrong. You know, the plants do roughly 15-20%, and they add a level of biocomplexity. They certainly set the stage for biocomplexity. We love them. But the main actor, the primary agent relative to cleaning up water, is number one on the food chain. It's the very bottom of the food chain. These are biofilm-generating bacteria. They and their residue are biofilm, and that's what coats the surface area of Biohaven floating islands. Biofilm reactive capability is key to our efficacy, and you can see it working in wastewater facilities, you can see it working in the ocean, and everywhere in between.
So aside from in wastewater in the ocean, what do you think the other applications for Biohaven technology is?
You know, it's hard to find the waterway that won't benefit from more wetland effect. When you concentrate nature's wetland effect, you can clean up water, and you can do it so much less expensively than conventional pop-a-pill human technology systems. Nature as model. It doesn't get better than that.
What are the main benefits if I install a Biohaven in my lake? What are the main benefits that Biohaven is going to bring to my lake?
If you start from the very beginning, if you begin to ask the question of how nature works to clean up water, what floating islands are Biohaven floating islands are essentially nature's concentrated wetland effect. And what that means is that as biofilm occurs within the non-woven matrix of a floating island and water moves through that matrix, that the suspended solids in the water bond to it. That blend of biofilm and whatever bonds to it is called periphyton. That's the base of the food chain. By growing that biofilm and then by purposefully, designably circulating water into and through it, we can begin the process of transitioning water from its typically low dissolved oxygen, high nutrient load, into waterways that grow huge volumes of higher order life forms like fish. In fact, here at Fish Fry Lake at Shepherd, just today we had 9 or 10 kids fishing, some of them for the first time. Youngsters, 10, 11 years old. They caught 30 or 40 fish in the space of an hour. They had a grand time. After the actual fishing event, we sat down with the kids and we asked them where they'd been before and what they'd done and what they noticed about the differences between where they'd been before and Fish Fry Lake. The usual things came up. The water was clear. There were a lot of fish. We got lots of bites. It was really fun. It's the kind of water you like to be around. It's why humans value being around water. We can have that again. It's at our fingertips.
And how extensively has Biohaven technology been tested in the field?
We opened our doors commercially by establishing a licensing business model back in July of 2005. New Zealand kicked it off, and New Zealand has been doing incredible things with Biohaven floating islands, from lake restoration to wastewater systems to stormwater management, all of the above. But we also have an additional 4 manufacturers based here in the U.S., another one in the People's Republic of China. Between them, today, over 5,000 islands launched around the world, everywhere from Alaska to the Gulf of Mexico to New Zealand and China, freshwater, saltwater, and everything in between, including rivers.
So what are the implications for this technology globally?
You know, I feel like it's hopeful. I feel a sense of hope. And what I guess there's so many reasons for this, but one of the big ones is that when water professionals get a grasp on this new tool, when they begin to understand that at their fingertips is an ability to concentrate nature's wetland effect and ultimately get back to how it could be. The actual, we think there needs to be another name for waterways, in fact. You have oligotrophic, you have mesotrophic, and then eutrophic, and even hypereutrophic. Now we need a new name for what happens when we take a hypereutrophic waterway and we start to cycle those nutrients back into something healthy, like fish. A whole new classification that we're calling transition waterways.
But you believe this technology can also have huge applications for improving wastewater effluent?
As I said earlier, we haven't, it's very, very difficult to find a waterway that won't benefit from more of nature's wetland effect. Whether it be wastewater, which or CAFOs, confined animal feeding operations, or stormwater ponds, or dead zones in the ocean. I mean, we're talking about everything from aquariums to dead zones in the ocean. And the same principles apply. Certainly there's differences between saltwater and freshwater, but when it comes to human beings and our nutrient loading around water, we now have an ability to take those nutrients and do something way better than letting them cycle into cyanobacteria or blue-green algae, sometimes which are toxic, and instead to produce something actually valuable and something associated with why we value water, why we live around water whenever we can. At least in most settings. Today there's places where the water quality is so bad that people don't want to live around it. We can fix that.
Bruce, thank you very much.